Hello students, let's look at the 2023 Edexcel GCSE Computer Science Paper 2 exam, which is half of your GCSE, 75 marks. Please make sure that when you open up the student coding folder, you immediately save a copy in the completed coding folder as finished, so that you're not overwriting the original file, and you can always refer back to it if you need to, and then it will just make sure that you're not going to have issues during the exam. So you're going to have the completed coding folder. You should put your finished files in, and you've got to make sure that you call it like Q01 finished, uppercase, no spaces. Just take that moment to make sure that you're doing that properly to avoid any stress. Okay, a program has been developed to show the average daily temperature and add up to a cost of buying ice creams. We've got constants that are always written in uppercase. Global variables, very typical for Edexcel GCSE questions to have global variables that we initialize with a certain data type. If we don't know what the values of A cost or total are yet, we initialize them first, so that they're known to the program and that's a real number float. Let's have a look. I would imagine all of this works. You want questions like this where you just simply put the line number of what you need to do. And there are 7 marks and there are 7 bullet points, so literally tick them off as you go. Name of a constant. Well, there are 2 here. I'm just going to borrow what's there. I'm just going to double click so I don't make any spelling mistakes. Don't write lowercase discount 5. Okay, it's just not worth the problems. Name of an array. Well, the temperatures. An array is when you've got a Python list with the same data type in it. Line number of an initialization of a variable with a real number. Well, there are loads of them. A cost, that's a real number. Discount 5 and 10 are as well, technically. So I can't see any problem with that. Yeah, that's fine. Line numbers of a selection construct. Line numbers, plural. Sequence selection iteration. Okay, so where's the selection? 27 to 29. Just to be safe, you could say 27 to 30. Don't put one number. Do not put one number. If you just put 27, you're not getting the mark. Line number or numbers, plural, for repetition constructs. They're talking about while loops here, because the other one is iteration. Anytime you hear the word iteration, it's going to be a for loop. The for loop is on line 17. The while loop is a condition-controlled loop on line 22. Simple. Line number for an instruction that outputs information to the screen. Well, look, don't overthink it. I mean, literally, there's one right here, print 32. There's one on 18. That's what goes to the screen. Use the easier options first. Obviously, technically, that's in the screen as well, so you probably get a mark for that, but go with the print statements. Simple. That's question 1 done. You want questions like this where you can rack up some points. A program is written for an exercise routine. It displays the names of warm-up exercises stored in an array. Okay, so here are the exercises. Right, already we've got a little problem here. 8 marks, 8 bullet points. Fix the syntax errors. Well, random would be the first thing that I've noticed here with a O, random module. For exercise in fix the syntax error, well, we're missing a colon. We're missing the colon at the end. We can already see glaringly obvious that there's an issue with our string here. So that's one as well. Index error on line 21. So what's going on here? Pardon me. Well, we're getting ahead of ourselves. Let's just calm down. I'm rushing a bit. Fix the name error on line 22. Well, obviously, that should be just name. fix the index error. So name exercise table +1 is a problem, isn't it? Because you wouldn't expect to have that, or index, because we start from 0. So that's that issue. Fix the logic area on line 19. For counting range of number exercises -1. Well, we've got how many exercises do you need? 1 to 5. We don't need this -1 bit here because we go up to but not including. So if they put, that's a stop value. So if they put 5, I'm just going to put this in as a comment. It would do 0, 1, 2, 3, 4, stop before 5 runs. Which I know is a bit weird, but it does 5 things. It goes from 0 up to 4. Okay, that's at index 0, 1, 2, 3, 4. That's it, I think. Use white space to improve the readability of code. Well, immediately putting a little bit of space in there. I would probably put one here as well. It's a bit squished together, isn't it? Just, you know, spread it out a little bit. And that's an easy mark. It's an easy, nice mark to get there, just to spread out the code, make it more readable. Done. We're done with question 2. Question 3. A program is used in a shop that sells building materials. Fine. Okay. So we've got an array of strings. The program reads in data from a file. Right, okay, so we should have a text file here, screws, there we go. And what's in there? Okay, so we've got a record here. Each line is a record. Okay, so I thought it was getting a bit too easy. It's started to ramp up more difficulty now. It's fine, we can do this. We can definitely do this. Let's read it. The program outputs the number, reads the screws from a file. Okay, the program counts the number of copper screws. That's fine. Then the program stores the names of the bricks in an array. It writes the names of the bricks to a different file, 1 per name. Oh gosh, there's lots going on. The output shows 26 screws were read from the file and 5 were made from copper. Right, so yeah, surely we wouldn't be expected to write all of that for a question 3. So we just need to choose the correct ones. Okay, amend some lines of code, choose alternative lines of code. Fine. So it makes sense for our total to start off with 0. It's an integer, doesn't need to be a float. It's not a string and it's not a Boolean value. So just uncomment what you need. Outline, it's also really typical to have outlines in questions that involve reading and writing files, because we usually are building up an outline string to write to a file. So having an empty string makes a lot of sense there. Our main program, let's have a look, process the screws. Okay, so we are reading, opening a file in read mode because the file exists. So in file makes sense. Input file, well, yeah, input file will be, well, let's have a look. We don't have, it says add the correct input file name. Okay, so what it is screws.txt, and I'm literally going to copy that with the extension and pop that in as a string. I've got to make sure that I've got the case, it's case sensitive plus the extension. Extension is really important to have in here. Fine, okay. We've got some global variables in here, that's great. We've got our, complete the line with the correct variable name. Okay, so what is the variable name? is there a clue down here? Brick table. It makes sense, doesn't it? It makes sense that we have to call it brick table. So that brick table equals all of our values in our Python list. Okay. Process the screws. Right. Okay, let's go back to this, because this is what led me onto that little rabbit hole of just making sure that we're going methodically going through, sort of racing in. We've got an input file now called screws.txt, so therefore we can use input file in read mode. We're not using append, we're using read mode to open it. Screws is the wrong one. For line in file, so we've got for each loop, and then what we want to be doing is -1 is when we can't find something. So it makes sense. Specified material, copper, specified material, right? If the line.feed, this is a method, find specific material copper, does not equal -1. So if it equals -1, it's not there. -1 is another way of saying I didn't return it. So if it does not equal -1, then we can say it's found. And then complete the line to increment the total. So total equals total plus 1. Now, of course, you can say total plus equals 1, but it just says don't amend the code or add functionality, so just keep what it is there. Okay, so yeah, so -1 is when we don't find something, and does not equal -1 means we found it. And then we can say found count equals 1, and then increment our total. Good. We always need to close the file, so in file is the name of the variable that we've put it in, and it's close. Okay, in file.close. We always want to close it once we've been reading it. Now we're reading it, we want to be, eventually we're going to write as well. Choose the correct line to display the output. So we can say total screws equals string of the total, like we're looking for copper, let's say a string is total plus a space, specified material copper, screws, string, I think that's the right one, specify that last one. And we can always run this because it should display this if it runs. Okay, that's what it should display if it works, which we want to use to validate it. And then finally, processing bricks. The output file is the name that we've bricks. Add the correct extension. Okay, so we need, it's always going to be a text file, so we want to make sure that that's there. I'm glad I checked that. So output file open in write mode, not read. And then we're going to use a for each loop for brick in brick table. Can choose the correct line to convert to uppercase. Well, that's just the, even if you didn't know what was going on with this question, you'd at least be able to read that in the PLS subset document. And that's the method for not checking if it's uppercase, but making it uppercase. Complete the output line. Well, we want to have a new line character, \n at the end, just like a character return or pressing enter. And we want to then write our outline, which is our string, outfile.write, and then the string, which is the brick in the brick table with a new line character. And then finally, choose the correct line to display the output. Well, we're not using format here. Format is when we've got, you know, 2 decimal places, and you can do center justified, which is worth learning about. You do need to know about that. We can just do the Brit names to wrote something to file. It literally says here, wrote 12 brick names to file. So I think the most appropriate there is length. Right, moment of truth. Let's run it. Yes, it is exactly as we expect here. Now, if you're really confused with this, you simply can guess some of these. You've got like a 25% chance. But when you're dealing with files, we're almost always using an outline string, updating our totals. The files extensions should be easy points. The variable name for the array of bricks. Most of this is fairly common sense. That's an easy one. Out close. We have to write a new line character. So you do need to brush up a little bit on, that's probably the easiest mark there. Brush up on your file reading and writing. I've got videos on that as well, separately. Let's move on. That was a pretty chunky question for question 3. Question 4. Right, we're going to have to do most of this ourselves by the looks of it. A program is required to calculate the volume of a prism. Fine. Well, it gives us some formulas to work with, so we don't have to remember that from maths class. All dimensions are entered by the user. Fine. The dimensions are decimal great numbers. Decimal numbers, real numbers, floats. Greater than 0. So we've got sort of validation that we need to deal with here. The volume is the area of this triangle multiplied by the length of the prism. Fine. And we've got the area of the triangle, and we've got the length of the prism, L. Global variables. So what are the global variables going to be? That's what you want to start thinking about here. We've got a whole load of them. A whole load to put in here. It's literally everything that you can see here. So height equals real number, not an integer. Base. I'm literally going to copy this because it's going to be quicker. What else? Length. A for area. Volume. These are all default values for global variables that can be used throughout the program. Is there anything else? Display the volume of the prism using string format function. Right, in 8 columns with 2 decimal places. This is a bit tricky, but we can do that using layout equals, and we can have a string layout. And basically, anytime we have these curly braces as a placeholder, so we can say volume is, it literally says okay, cubic units. So I'm going to copy and paste that, cubic units. Now, what does it say? Now, the way to get the center justified, does it say center justified? Hang on. 8 columns. So I'm probably going to start with this, and then 2f gives us two decimal places. Sorry, it should be dots, shouldn't it? This is it's written into the PLS subset document, if you can't remember the layout, how to use layout. So this says, okay, we're going to put a variable in there, and it's going to be left justified by 8 character spaces, and it's going to be 2 decimal places. So I think we've got our global variables sorted. I should read the rest of the question. I'm braced in there. Okay, fine. It does tell you what to do, so we really want to be checking off as we're going here and reading through these bullet points and check them off as we go. Take 3 decimal inputs from the user. Fine, and it tells us here take 3 decimal units, so let's make some space for it. Bit of white space as well wouldn't help. So what do we need from the user? We need to know the base, the height, and the length. If we know those, we can get the area, can't we? So I'm just going to borrow these. We've initialized the default values. And what was the other one we need? Height. Now we need to make sure they're all floats. And we need to make sure that we're using input statement to get the values from the user. Enter the width of the base of the triangle, colon space. Just to avoid errors, I'm going to basically copy that. Oops. Enter, and then just change the text accordingly. Enter the height of the triangle. Fine. And then we need to enter the enter the length. Prism. Triangle. Good. So we've got that part done. We can literally check it off as we go. Just like with it, when your exam, just get your pen and say done. Now all inputs must be greater than 0, so we need to check for validation. Check for invalid inputs using relational and logical operators. So it makes sense here to just construct a big if statement. I always have my colon at the end, and I'm going to put all 3 of these in brackets just so it's easier. So if either one of these is less than 0, then we can stop it. So I'm going to use or for this, because it doesn't matter. They don't all have to be that. It just literally, if any one of them isn't that condition, then it's not going to work. So we can say if height, well, let's say no, sorry, this is base. Let's go in order. If the base is less than or equal to 0, or the height is less than or equal to 0, or the length is less than or equal to 0, and we'll use floating values here as well because it's all in floats. Then we can say we've got a problem. Now we've got to make sure that after this we'd have an indentation, because there's a load of comments in here which could kind of confuse you. So you just got to make sure that we're indenting. Print invalid input. Done. Well, yeah, that's fine. Whatever. Okay. Else, then we can do the rest of it, can't we? We can actually make our calculations. So we've done this. We've checked. We've got the inputs. Check for invalid inputs using relation. We've done this. Display an error message if an input is invalid. Yeah, we've done that. Process all valid inputs, calculate the area. So we essentially now we just want to calculate the area of stuff. So what is the area? Area equals of a triangle, it's just half base times height, isn't it? So you could do half in 0.5 or put 1 over 2 times the base times the height. Half base times height. That's our triangle, right? Display the area of a triangle. Rounded to 2 decimal places. Fine. So it's going to borrow that print statement, save me some time. Area of triangle is, and then I like using the F formatter string to make this look neater, but just if you don't know how to do that, or if you're using curly braces, if that's confusing for you, then just use your sort of basic way of doing it using commas. So I can say area. Now I've got to make sure it's to 2 decimal places, so I'm going to use the round sub program, and that parameter is the number and then the amount of decimal places. It's probably the easiest way of doing it here. Okay, so print area of triangle is rounding up to 2 decimal places. This is also in your PLS subset document, so you can guess some of this stuff. Calculate the area of a prism. Sorry, calculate the volume. Now the volume is the area of the triangle, which we've already got, times by our length. So that's pretty straightforward. Display the volume of the prism using string format. This is the tricky bit. I say it's tricky. If you've done this, then you've done the hard bit already. So the way to use that, and it is also written in your PLS subset document, use a print statement, and then you can say layout, and then it's a method dot format, and in our brackets here we can put I'm going to say volume. I'm going to put volume in there. So volume will go into this. So the layout was relates to this. Format is the method that we're using, and that's saying, okay, whatever's in the curly braces is going to be replaced with this value, which is our updated for a variable, left 8 characters justified, and then 2 decimal places, and then finally print goodbye. Make sure that's a string. Right, let's run it and see if it actually works. So we've got the base 4.567, enter the height 1.23. I'm using the numbers that are in here. Length 89.01. 2. Yeah. There we go. There we go. I think that's okay. Let's try just another one. 2.74, 6.81, 5.55, 8.23, 45. Okay, there you go. This is your essentially your table, kind of like your trace table, for checking that your algorithm is working as intended. Good. I think we're all right then. Display the volume of the prism using string in 8 columns with 2 decimal places. Yeah, I mean, it's hard to see where the columns are, but I'm pretty sure that's what they're asking for. Good. Okay. Well done. That's again a pretty tricky question. It started off quite easy on question 1 and 2, and then it's got quite harder, hasn't it? A program is being developed to generate user identification. So we've got ASCII in here, letter, string and made up of the last name joined with the first letter of the first name. Okay, so like initials, kind of like authentication, the number part of the identification, some ASCII values, day, month, year. Okay, we've got some data. So Viola would be, so the first, it's the surname, first initial of their forename, and then this 403. So we can validate what we're doing, whatever they're asking us to do. We can validate it this way. So let's have a look. We've got some code for us already. Amend the code to ensure local and global variables with the same names are not confused. Right, fine. So how's this going to work in terms of these? We're not touching these global variables. We're not going to touch them. Not going to touch those. With the same names, yeah. Okay, I'm not confused. So I think what happens, what they're asking for here is that don't use the same variable names here. So if we're passing through, we're calling our sub program here, subroutine. Now it doesn't matter what we call these, they'll just get passed through as arguments into these parameters. Well, I say it doesn't matter. It doesn't matter. It does matter what we call these. It doesn't matter what we call the parameters. So we could call these something else. So I'm going to say the parameter P for parameter last, parameter first, parameter date of birth. Let's go with that, and let's also go with uppercase because camel case is better there. Because whatever we pass through as a this argument can be, the parameter names can be different. Yeah, I think that's what they're looking for. Okay, ensure local and global variables. Obviously, these are global variables. Whatever we're using inside here will then be updated. So we need to say anything that we said as a local variable, last, first, parameter date of birth. Yeah, this is fine. So these local variables that are happening, they're being used inside the subroutine, are not using the exact same names as the rest of the code. I think we're okay now. Good. Okay, so we can tick that off. Welcome the user. Okay, call the welcome procedure before taking input from the user. Fine. So first and last name. But we've got, it's a bit messy, isn't it, this code, but add a procedure with no parameters to display a welcome message. And I think that's what they're getting at here. So we always have constant, any modules, constants, global variables, and subprograms, and then finally main program. So DEF, welcome user, no parameters needed, and it simply is a procedure that will print off a value string. And just say welcome to the program. That's it. There you go. So that's done. Call the welcome procedure before taking input from the user. Right, so this is where we need to call, and I think it's saying here, call the welcome procedure. I'm going to add some white space in here because it's so congested. All we need to do is simply use the name. I'm going to copy and paste here. we can just call the procedure. It prints off already, and we can say, add a comment and say, welcomes the user. I'm going to put procedure just to impress the adjudicators. Welcomes the user. So I'm going to put in here local changed. There you go. We just want to show the examiner that we know what we're talking about. So we've done that. Ensure the last and first names are all lowercase. Okay, so we've got methods for that. Converts first name and last names to lowercase. This is in the PLS subset document. So we can just simply say, we can update the variable. And we can say first name and last name, or last name, first name, equal first name dot lower. There we go. There we go. So whatever they've typed in, if they had caps lock on, it's going to force it to be lowercase. Validate the date of birth in the main program using the built-in string manipulation subprograms. Right. So we've got all sorts of subprograms like is alpha, is digit, those kind of things. Let's see if we actually need to use any of those. Check that only digits. Okay, there you go. And by the way, that's in the PLS subset document. So what I'm going to do here is say if date of birth is digit, if it is a digit, then I can check. Okay, yeah, so that's going to do that bit. And then what I want to do is have these indented in my conditional statement. So if the date of birth is a digit, call the subroutines subprogram with those arguments and print it off. Print your ID, fine. And then else, all the comments make it difficult for indentation on this. Print invalid date of birth. So think now we're probably okay. So we've done this. Generate the correct number part of the identification string in the make ID function. So here's the function make ID. Let's just check we're doing this correctly. If it's actually written correctly, there might be a problem here. So name is an empty string, name part, number part is 0, that's fine. Name part is last plus the index 0 of P first, that's the letter. Correct the logic error. Okay, we've got a logic error here caused by the int function in the number part. Okay, so when we're dealing with ASCII, we can either have the order of the character or we can do reverse engineering and find the character at CHR. So it's like using CHR ord. And these are in the PLS subset document. You just need to recognize what they do. So instead of getting the integer of a character, we're getting the order of the character. That's the order in the ASCII table. So I think we're done. I think we are done. Now, what we want to do is put last name, Basir, first name, Viola, and the date of birth was the 15th 06 of 2005, and it should give us exactly the same as what's in the question. Basir V403, correct. So we've generated the identification string. It's all lowercase, and we're matching what's in the question. Good, let's move on. Last question. Right, two-dimensional data structure. We've got these records here, which are implemented as Python lists. They are arrays, technically, as well, because they have the same data type in them. A program is required to determine if a user can access a database. So it's kind of like authentication. That seems to be the theme of this one. The names and the passwords of users are stored in a two-dimensional array. Right, open up the file. Yeah, so we have it open. Write a program to meet these requirements. So the main program is going to be written here, but your global variables need to be up here. So don't start writing and just carry on. You know, you've got to be careful to put things in the right place. Prompt for and accept a username and password. Well, we don't know what the name is yet, so we're going to initialize those. As strings, so that those variables are known to the Python program and the data type is assigned to them, and we can update them when we know. Searching the array. Okay, so we essentially want to look for a found, I guess we can call it found name if we're looking for it, found name, and usually start off with false unless we find it's true. Boolean, we'll put a comment in here because I'm pretty sure it's going to say, yeah, use comments, found username. What else? Implement, display a suitable message. If a user can access. So I guess we can say we found the name and we can let them in. We'll start off false until we know that. Because we've got their name and their password. Also, when we're traversing these with a for each loop, we want to keep track of our index. So we'll make a global variable called index. And we can say user replaces empty string. Right, so don't get ahead of yourself and just start coding. Think of your global variables first with these kind of questions and put them in as best as you can. You can always come back here and add them in. My question mark is over this one, whether that's appropriate or not, but we'll soon find out. Okay, write our code here. So we have to come up with this from scratch. So the best way is just to use, well, we need to ask them inputs. So let's just get the input. So we can say get user input. That's what it's asking for first. So I'm going to put these input down here, and I'm going to put input because we're getting input from the user. Enter your username, your name, just say your name. Enter your password. Because Again, like if we're using key value pairs dictionaries, if we were actually doing this, probably not just Python this, but that dictionaries are not in the Edexcel specification for GCSE. Enter your password. Okay, so we've prompted for that. Now we want to check neither should be blank. So we've got a conditional statement here that we've got to build up. Let's put some brackets in here because it's going to be kind of if the so the easiest way to see if it's essentially the length, check the length of the string. That's probably the easiest way to deal with this. So if the length of name, just make some space here so it's easier to see what's going on. If the length of the name does equal 0, right, let's put this into its own set of brackets, so it's its own clause, if you like, or the length of the password, because either of them. And again, I'm going to just copy and paste in the variables to avoid errors that could waste time during the exam. So if either of those are length 0, then we want to say invalid input. So that's our validation. Neither of them should be blank. We're done. Implement authentication by searching the array for the usernames, for the user's name and password. Fine. Okay. So we've got this two-dimensional data structure. Let's put else. So essentially, if we've checked those two things, and we're going to put in here, why did we do this? No blanks allowed. So else we can process it. Obviously, we'd probably in real scenarios would use something called try and accept, but again, they're out of the scope of the GCSE. While let's think, how are we going to do this? Let's just work on. I'm thinking, what's best? Is it going to be a for loop or a while loop? I think because we've got conditions here, Boolean values, I think a while loop is probably the best. So all of these can be processed. And what I'm going to say here is while these conditions are the way they are, we're going to carry on our loop. So what are they going to be? What are our conditions going to be? Found name. So while not found name, it's like the opposite. So if found name is false, not found name is true, they will have to be true. If not found name and we don't want to go beyond the scope of our two-dimensional data structure. So we're going to say index, put in length of index is, no, not length of index, sorry. Index is less than the length of whatever we're calling this, user table. Put the brackets in. If not false, so true, and the index is, so 0 is less than the length of the user table, because we're going to add to our index as we go around. Then we can carry on a while loop. So what I'm going to say here is if we use a table put some brackets in here. If use a table, now we've got index, and then we want to check the very first thing here, the username, 0, it's always going to be 0 there, and index starts off being 0, so that it's going to look at this one, and then 0, 0 is going to look at that, and then 1, 0 would be this, and 2, 0, etc. So if user table index 0 does equal our name, then of course we found a match, haven't we? We can say found name equals true, and then not true would be false, and this while loop doesn't need to run anymore. So we can say stops the loop. Else, are we done with that? No, maybe not. Let's have a think about this. We want to check the, no, if we found the name, then we want to check the password, don't we? So if that condition's okay, then we want to say if, I'm going to borrow this, index 1 is the password, equals password instead of name, then we can say, yeah, and that's why I wanted this one, let me in. Let me in equals true. Okay, good. I think this is okay. So we can say passes both checks. Good. And then we need an else. Just increment our index and look at the next one. So, you know, if we check this one and that condition's not met, we haven't found our username, then we simply update our index and the while loop will go around again. And this time index will be 1, 1, 0, etc. Now, what we want to say is just a suitable message. So that what's the output? We haven't done this yet. So we've got our while loop. That's going to handle whether we found let me in and found name. Then we can say if let me in, and it's the same way, same as saying if true. Then we can say welcome, because they've passed both of the checks. Else if we only found their name, then we can say print the password was incorrect. You know, we found your username, password was incorrect, and then else we didn't find them at all. User was not found. Whoa, gosh, okay, so enter the name. Do we have any validation? Yeah, when we do. So let's put L Armstrong. And the password, I'm going to deliberately, no, I'm going to use the right one first. Let's see if it actually works. It says welcome. Okay, good. And then let's run it again. This time we'll put a different password in. Like they forgot a password. Password incorrect. Great. So we know their username was there. And now let's try putting in the wrong username and some random thing. User not found at all. It works. Fantastic. So we've got through the whole exam. If this is helpful, please let me know in the comments, and good luck with your preparation for your GCSEs.